Well, greetings, Mr. Kolazar's class. We're going to now put together the empirical to find the molecular formula. So this is going to be video 10.4, part 2. And we're going to be looking at now the molecular formula, not the smallest whole number ratio, but the actual chemical formula. So there's 3 parts to this you have in your notes. They're kind of listed out in a box. Step 1, 2, and 3. And step 1 from before was find the empirical formula. So from our last section, we did 4 steps. Find the percent composition to change to mass, just going by assuming there's 100 grams. 2, go from mass to moles. 3, divide by the smallest mole number. And 4, obtain the whole numbers. From there, step 2 now, our new step, experimental molar mass, so this will be given to you, or you'll find it in lab. So either it's given or you'll be given that from a lab result, is your experimental molar mass, how much it actually weighs. You're going to take that divided by the empirical formula that you just calculated to give you some ratio or number. We're going to call that n, which you're just going to use n to multiply by the empirical formula to find out what your actual molecular formula is. So we'll go through those steps now to show what we're talking about. So we're going to start out with the problem. Chemical analysis indicates an unknown substance is composed of 45.71% carbon, 10.45 hydrogen, 30.48% oxygen, and 13.3% nitrogen. And it has a molar mass of 210 grams per mole. That'll be important later on, but not right now. So first off, to determine the molecular formula, our first step is we've got to find the mass of the empirical formula. So from our last section, we assume we have a 100 gram sample. So if we have 45.7% carbon, it would be 45.71 grams. 10.45 grams of hydrogen, 30.48 grams of oxygen, 13.3 grams of nitrogen. So once we have those masses, we need to go from mass to moles to find the small, and then divide by smallest mole ratio. So from our PT, 12.01 grams of carbon, 1.01 grams of hydrogen, 16 grams of oxygen, 14 grams of nitrogen. So when we divide by each of those to get into our mole-to-mole ratios, we end up with each mole of carbon, hydrogen, oxygen, nitrogen. Now as we go down the list, the smallest number we see, 0.95. So we are going to divide each one of those by the smallest mole ratio. And in turn, 4.01, 10.89, 2.01, and 1.0. All of those are close enough to a nearest whole number. So what we're going to do is we can use those 4, 11 moves on up, 2, and 1 to get us our empirical formula, C4H11O2N. So now we're on the right track. We have our empirical formula. So our next step was, it said to find the molar mass of the empirical formula. 4 carbons, 11 hydrogens, 2 oxygens, 1 nitrogen. We need to use our periodic table to find the mass of each one. We have 4 hydrogens, 11 hydrogens, 2 oxygens, and 1 nitrogen. So as we're going, 48.04 grams per mole from the carbon, down the line. To total or add those up, we get a molecular mass of 105.16 grams per mole. So that's how much this compound's empirical formula weighs. So that's the molecular mass of just that empirical compound. So we need that mass coming up. Our step 2 says the experimental molar mass divided by the empirical formula's molar mass, or the mass of the empirical formula. So we have the mass of the empirical formula we just calculated. Now what we need to do is the actual experimental value from earlier from the assignment or the question said that it was determined to be 210 grams per mole. Now when we divide those two, you're going to see that we come out to a number that's just about 2. We're going to round it to 2. It's close enough to 2 to round to actual number 2. So that's going to be our n value. It's going to be what we're going to multiply our formula by. So that whole number there is 2. And so what we can do then is our formula, this was our empirical formula. Empirical formula is going to be multiplied by that number n, which was 2. So that 2 is going to be multiplied by each of our subscripts there, and in the end we now have C8H22O4N2. That would be our new molecular formula, which could reduce down, dividing by 2, to C4H11O2N, which would again be our, oh, there it is already, our empirical formula. So that's one of our strategies for calculating our empirical formula, our molecular formula. We've got a second problem to work through. Some of it's already been set up on this page for you. So NutraSweet, 57% nitrogen, 6% hydrogen, 9.52% nitrogen, and 27% oxygen. Its molar mass is experimentally determined to be 294.3 grams per mole. Now this one has one unusual part to it, so we want to show that. So first off, we're going to assume 100 grams, so 57.14 grams carbon, 16 grams hydrogen, 9.52 grams oxygen, 27.18 grams of oxygen. So as we're going, periodic table, to get our molecular mass, grams to moles, so grams will cancel grams. And we're now left with our moles of each one. 4.6, 6.1, 0.68, 7.1. Divide by the lowest mole number, happens to be 0.68. So if we divide each one by 0.68, we end up with 7, 8.97, 1, and 2.5. Now 2.5 is a problem. That can't be we can't write, a formula that has, H2O 2.5 or something like that. We can't have a 2.5 in there. So we need to instead get this to a whole number. This was that last step, or step 4 of the problem earlier, or step 4 of our notes that asked us to obtain whole numbers. Since 2.5 is a decimal, we're going to end up having to double it in order to get it to a whole number. So all of these will need to be doubled. So now we've doubled to 14, to 18, to 2, and to 5. So our chemical formula, our empirical formula now, C14H18N2O5 is going to be our empirical formula at the moment. Now we've got to go one step further. Molecular mass, if you were to calculate molecular mass out for each of these, our molecular mass total 294.34. Now notice our experimental data given from earlier showed it to be 294.31. So when we divide these two numbers together, we get an answer of 1. So if we were to take times 1 by 14, 18, 2, and 5, our experimental data divided by those, our empirical formula and molecular formula are the same. So this chemical formula for NutraSweet, H18N2O5. So calculating our molecular formula, we've got to go that extra step, knowing the experimental data or information in order to actually calculate for it. We'll go ahead and stop there, and then we'll pick up with hydrates when we get back.